Let's learn about the law of sines and the law of cosines. We'll learn about what, when, why, and how do I use each. We'll learn about the ambiguous case with the law of sines, and we'll talk about some calculator tips for solving with the law of cosines. Let's get ready. You're going to need notes and pencil. And for your calculator, you want to make sure it's in degree mode. Press mode button and then go to the third line to convert from radians to degrees. The law of sines, you can use either one of these, and it's a relationship between the sides and the angles of a non-right triangle. That's really important. We've done right triangle trig, sine, cosine, tangent. If you have a right triangle, you can use right triangle trig. If you have a law of sines, you're not using that on a right triangle. So it relates the relationship of the sine of an angle to its side. You're not usually using all three. You pick what you need and you would use that as a proportion. Or you can put your sides on top. Either one is fine for the law of sines. When do you use it? Well, again, not for a right triangle, but if you are given angle, angle, side, angle, or side, side, angle, notice I put the asterisk there because that could signify that you could have the ambiguous case. With the law of sines, we do it so that we can solve a triangle. Solving a triangle means finding all the missing sides and angles. And how do we do it? We set up a proportion and we solve. And I'm going to ask you to undo everything first. Undo all of the algebra and then pick up your calculator. And we'll look at an example in doing law of sines once we get into this ambiguous case. So the ambiguous case might happen when you have side, side, angle. And I really want to stress that you should try to always draw it like this. The angle that you know goes here. This is a fixed angle. That's what's locking it into place. Then you put a known side here and then the known side over here, not down here, because we want to think about this as like a little piece that's going to move this back and forth. And if you put it down here, you can't really do it. This is like a kind of a hinge there. And you'll see what I mean in a minute. So try to always draw it like this. When students draw it like this, then that becomes side, angle, side, and that's something totally different. So let's look at all the different possibilities. If A, now remember A is the side across from angle A. If side A is bigger than side B, you will just have one triangle. Just go ahead and do it, and no problem. But if A is less than B, and again, all these dotted lines could represent A, so we kind of just talked about that one. That's going to give us one triangle. But now the others, we need to compare to the height. And now remember, the height is the perpendicular. So that means we need to find the height first. Sneak peek there. So we're going to find the height, and I'm just going to use this triangle here, which is a right triangle. So I'm going to use right triangle trig, and I want to find the height. So I have, go to 31. Across from that is opposite and my hypotenuse. So I have the sine of 31 equals h over the 6.5. So h is going to be 6.5 times the sine of 31, which is about 3.3. So for the next few triangles, that's what we're going to be comparing everything to. The height of this triangle is 3.3. Oops. So if the height is 3.3 and I give you an A value of 2, it's too short. So here we would have no triangle. If A is less than H, it's not even going to reach to make a triangle. If A equals H, they're both 3.3, then you have one right triangle, and you can go ahead and use right triangle trig. Now, the ambiguous case happens when A is in between H and B. So here's my height, 3.3. Here's my B. The problem becomes if A is something like 5. 5 could fit over here because it's bigger than 3.3. But it could also swing and be over this way. So this is a picture I like to use right here. If A can fit in between H and B, so let's like that's a 3, that's a 5, that's a 6. So it can fit in between there, then it could go both ways. So now we are going to have two triangles that we're going to have to solve. So we are going to go ahead and solve it as if A is 5. So across from A, we'll put 5. We'll keep in mind that we do know we're moving into the ambiguous case. So I always suggest solving for the bigger one first. So I removed the height. Now we have this. It is angle side side, so we're going to do law of sines. So I can do the sine of 31 is to 5 as the sine of b is to 6.5. And so when I cross multiply, I'm going to get 5 sine b equals 6.5 sine 31. Oops, I forgot my b. So sine of b equals 6.5 sine 31 divided by 5. That means that angle B is going to be the inverse sine of that fraction. And this is what I mean by undoing all of that algebra, so you can just take this in one step on your calculator. And you find angle B to be 42. Keep forgetting my B. There it is, 42. So then I would go ahead and I would find angle C, and I could do that with the triangle sum theorem. So I would subtract 42 and 31 from 180, and I get 107, and now I can find side C. So we just did law of sines once, then we did triangle sum theorem. So now I can do law of sines again. Stick with my sine of 31 is to 5, as sine of 107 is to C. You would solve it the same way. You don't have to take inverse though this time, so we get C sine 31 equals 5 sine 107. C is going to be 5 sine 107 over sine 31, and side C measures 9.3. 9.3. So we've solved that triangle. Now let's swing it. So here's my little thing, and we just did this as 5. Now we're going to swing it over here because this could be 5. And these are our steps and what we're using. It sounds like a lot, but stay with me and I'll go through it in more detail. So if this is 5 and we just found angle B to be 42, that means that this is an isosceles triangle. So I can use the isosceles base angle theorem that says if angle B is 42 there, then this one over here, we'll call this B prime, is 42 as well. So I used isosceles base angle. Now I went from here to here. Now I'm going to do linear pair postulate, and I'm going to move inside the triangle. And we know that this angle has to add to 42 to be 180. So we're doing the linear pair postulate, and we get 138. Teeny tiny in there, 138. And then I can go up here and I can do the triangle sum theorem and subtract both of those from 180, and I get 11. And now I just have one more step, and that's the law of sines. So just to recap, we did 42 from the previous, then we do the isosceles to move it over, we do linear pair postulate, and then triangle sum, and one more law of sines. I think I have on the next slide. Yeah. So we did this already. This was 108, this was 11, this is 5. So now with my law of sines, I'm still with sine of 31 over 5 equals sine of 11, and we'll call this side C prime of C prime. And then C prime ends up being 1.9. So we've solved both triangles in the ambiguous case. Let's switch over to the law of cosines. So we have all these 3 versions of them. And if you look at the third one, here we see the Pythagorean theorem. It looks like the Pythagorean theorem. So the other 2 are just kind of versions of that, whichever side you need to have first. Also, some other things to notice. Here's A, here's B. Oh no, I have a mistake. That was not intended. But that's supposed to be a B there because those are supposed to be the same letters. A and C, B and C, B and C. And then if you also notice, whatever letter, whatever side you're starting with is the angle at the end. So the letter at the beginning is the side, the letter at the end is the angle. B goes with B, C goes with C. It's always a subtraction here. This 2 is built into the formula, and then it is called law of cosine, so you're using cosines, not sines. So many times kids will do this and they'll put the word sine there. Go through a problem. We're going to use this when we have side, angle, side, or side, side, side. Just to compare, we used law of sines with angle, side, angle, 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 side, and side, side, angle. But law of sines, you have to have at least 2 of the sides. With your law of sine Tips, make sure you're undoing the algebra first, then calculate. And if you have side, 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 make sure you're finding the largest sign first so that you could avoid the ambiguous case. That's just my little thing to help you remember that. This is the longest side, so find that first and avoid the ambiguous case. So let's go ahead and try this. We have this triangle. All of those are lowercase. I'm going to just continue to draw it in the same order. So A, B, C. A is 25, across from B is 32, and C is 37. I see C is the largest, so I'm going to start with that one. And so that means I'm going to start with the letters. So C squared equals A squared plus B squared minus 2AB times the cosine of C. So I do know C squared, 37 squared. I know A is 25 squared. B is 32 squared minus 2 times 25 times 32 times the cosine of some unknown angle C. This is where I want you to undo the algebra first. Notice these are both being added, so I'm going to subtract them. 37 squared minus 25 squared minus 32 squared. Don't lose this negative. This whole thing is getting multiplied by the cosine of C, so I'm going to divide by that, including my negative sign. Parentheses negative 2 times 25 times 32. I'm going to put my numerator in parentheses too, so that all stays up there. And that's going to equal the cosine of C. So from here you could do the left and then get that and do inverse cosine, but angle C is going to equal the inverse cosine of that entire fraction. And we find angle C to be 80 degrees. So now this is 80 degrees. And good news is we've done law of cosines once. We can switch over to law of sines now. So we have sine of 80 goes with 37, and the sine of B goes with 32. We would cross multiply. Make sure you can do that. You will be using the inverse because we don't know the angle here. And angle B equals 58 degrees. So I'm going to plug that in. And one last step, just do the triangle sum. This must be 42 degrees. We've solved the triangle using one law of cosines, one law of sines, and the triangle sum. And that was what your final answer would look like. So the law of sines is used then, the law of cosines is used then, and next class we'll be practicing. Good job.